Hello, what I have here is the presentation of two programs in two instances of Eclipse. So on the left hand side I've got a class UDP stop and wait server. On the right hand side I've got a stop and wait client, and the idea here, the fundamental idea is that, well, I'm using UDP, the UDP protocol, to transmit data between client and server. And a little bit of research on UDP tells us that UDP isn't actually a reliable protocol. So I want to create reliability of communications here. And we're using the ideas that we've just explored or explored last week in terms of reliability. We're going to model a mechanism for gaining reliability. And essentially, what this involves is the idea that the server will send the next packet of data only when the last packet of data has been received by the client. In other words, the client has sent an acknowledgement packet. Uh, uh, Possibly a few complications which we'll might investigate time permitting, and it's this: what happens if the client sends the server an acknowledgement, but the acknowledgement becomes corrupt? Well, I don't think this program's terribly sophisticated in the sense. I don't think it's going to check whether or not an incoming acknowledgement is corrupt. Uh, but that doesn't matter. I mean, if we were to build in mechanisms like that, we'd probably end up very much sort of with a TCP-like protocol. So what I'm going to do now is to run the server, and see, this indicates that it's actually running in the background without giving me any information about what it's doing. And I'm going to run the client, and what happens is that the client has sent various packets with sequence numbers. Here's one with 52, and I think if you have a look, if you inspect uh, the console of the server, um, it's occasionally dropping a packet, and on the other hand, it's telling you which packets it's received an acknowledgement from, and so on. So it's quite interesting, and I think having a look at the program over here, I think we're just sending a limited number of packets. But the idea, again, to repeat myself, is that the client is actually going to send a packet to, sorry, the server is going to send a packet to the client, and the client is actually going to send an acknowledgement. So each of these uh, notifications indicate the receipt of an ACK. So therefore, the server can send the next packet, 49, 50, 51, 52. If a packet is dropped, I think it's going to be resent. Okay, so we're modeling losing or dropping a packet, and then perhaps resending it back to the client, and then waiting for the client to send us an acknowledgement. Okay, so I've finished there.